Hello everyone and welcome to this presentation list for GRAITEC. I will introduce you to we'll start with a quick general. Now let's have a look at advanced design. So what you see here is the first page. In the center we have so we can identify. We have some sample projects. And if you look at the bottom, we have two tabs. So if I switch to the tab, direct access to some web that we pushed. Now if you look at the configuration menu, we can see what languages and what code the software supports. So we have the Eurocode as well as Canadian and American code. So up to date. So right now it's the NBC 2015, the ASC 716. Choose the code for the load combination, seismic analysis, climatic generator. So we'll see some of them today. Reinforced concrete design, steel work, timber design, and for Eurocode we also have masonry design. Now let's have a look at an existing model to show you the interface. We have here a simple 3D model of a concrete structure. So it has columns, beams, and slabs. We also have a group of walls in the center. If you look on the left side, we have what we call the project browser. So this will list all of the elements that are part of the project. So both structural elements as well as all of the loading. The structural elements were grouped by levels and then by types of elements. So this makes it very easy to select them or to hide them. So if I wanted to select all of the column on level 3, I just have to right click and select. If I want to remove level 3 to work on the level below, I can just double click on the group and it all disappears. It's the same thing for loading. I could hide or show specific load cases or groups of loads very easily. If we look at the bottom, we have the command line, so we can use it to type commands or to type coordinate when we model. During the analysis process, this is where we'll see all of the warnings or error that could happen during the analysis. On the right side, we have the property panel. This will list all of the properties for the elements that you have selected. So right now I have a column, so we can see at the top the type of element, material, cross-section, releases if you wanted to add pinned connection or elastic releases, meshing options, and at the bottom we have some of the design options. So it's possible to filter this list so that it's easier to work with. So instead of showing all the properties, I could build my own filter and select only the groups that I need for my specific project. At the top, we have the ribbon toolbar. We can also add extra toolbar below it. So if there's tools that use very often and you don't want to always have to switch tabs, you can add them at the bottom also. So if you have a quick look at it, so the Home tab is the one we use the most for modeling. So this is where we have access to the main option menu. We can add lines, structural elements like linear, planar elements, supports. So for supports, we have three types. We have point support, linear support, and planar support. So the advantage of using linear and planar support is when you need to support like a slab or a wall. So instead of having to place many smaller support, we can just place one linear support like this. And the properties that we select for this support will be applied to all of the nodes that are in contact with it. So this can save you a lot of modeling time for walls and especially for mat foundation. Then we have load areas. So if you've worked with Advanced Design America, this is the equivalent of the walls and the floor elements. So we'll use them to distribute loads and to use with the load generator. Then we have loadings, we have some modeling tools, selection tools, as well as some tools to manage the view. So hide or display elements, change the view, manage the work plane and the 3D render. So if you wanted, for example, to remove the shading or to add it back. The object and utilities tab are modeling tools are a bit more advanced. So objects is mostly for generating new elements like portal frames, structures, load areas, supports, pressure, and so on. Utilities will be mostly to modify existing elements. So to have openings in a slab like we have on this model, to convert one type of element to another, splitting load areas, merging elements, and other tools similar to that. Analysis is all of the options related to design and analysis. So we have our mesh options here. We also have some extra elements that we can add after the meshing process. Results, this will be for post-processing of the results. Currently it's all grayed out because we've not launched the analysis yet. In documents is some tools to help you generate documents. So we have templates that we've created for you. The BIM tab is all of the import-export. If you're working with Advanced Steel or Revit, it's better to use the GRAITEC format so it would transfer more information. It's a lot faster. But if you need to communicate with other software, you can use the IFC, SDNF, SIS2, PSS, or DXF format. We also have a direct link with EDS-ICA, so you can send the geometry and the analysis result for a connection. The Manage tab is for all of the option menus as well as all of the libraries. So cross-section, materials, soils, and if you wanted, let's say, to change the units, you could do it here. And finally, design module. So this is for the concrete detailing. I will show you it later today. Advanced Design has multiple load generators you can use. So you can generate wind, snow, pressure, as well as moving crane loads and seismic loading. So the two I will show you today is wind load and snow load. Let's move on to a different model. So to generate climatic load, all we need is load areas. So we don't actually need the structure under it. So the load areas will be used to distribute loads and for the generator to understand the shape of the structure. If we look at the roof, we can select if it's exposed or not to snow. We can also select if it's a slippery surface or not. For wind, we can also completely turn it on and off. And we have a dialog box for CP and the CPI coefficient. So now to generate loads, I need to add the correct families. I'll go to loading and then right click, add a case family. So you can see the different types of load we can include. So dead, live, snow, wind, seismic, temperature load, accidental load, dynamic temporal, traffic loading, crane loads, and pushover. So I'll select the snow NBC 2015. Then I have a couple of options I need to set. So we need the correct SS and SR value. If you already know the value, you can enter them directly. But if you don't, you can pull them from the code. For the Canadian code, it's based on the Annex C. You have to select the correct city in the list. So I'll select the Quebec City. So it gives me SS and SR automatically. Then the CW coefficient, I have to set it myself. And when everything is correct, I can right click and use the automatic generation option. So AD will automatically create 3 different load cases. So the first one is the normal snow. Then we have snowdrift in the X positive direction, and then snowdrift in the X negative direction. And as you can see, it was very easy to create. It only took just a couple of clicks. If I want to do the same thing for wind load, same idea. So I will create a new case family with the wind in BC 2015. Then there's a few more parameters here. So the first one are more general, like if you want to split all areas or not, and which wind direction you want to generate. So currently, all wind direction will be. Then we can also select a region. And it will automatically select the pressure. So it looks like it was already set as at this city before. Then for the C, we can select the correct formula or manual enter the value. We have then the other coefficients, so CG, CGI, and CD that you need to enter manually. And then we have the height above the terrain. So I won't go into detail about each of those parameters, but once you've set them correctly, right-click automatic generation, and you get all of the wind loads. So as you can see, we have 8 different cases. So if I bring just one of them at a time, so it's a bit easier to see. So I scale them. So I turned off the wind on this small roof so that we get a better look at this. This is one of the cases. So this is wind in the X plus direction with one set of CPI coefficient. In the other direction also. Y plus and Y minus. So if we look at one set of them, so the inside the load case, so all of the wind loads we have commentaries to tell you what region it is, the CP, CPI coefficient, and also the loads will be named after the element. So let's say I were to rename this load area for a roof 1. I can very quickly regenerate the loads if I've made changes to the structure. So I can just use again the automatic generation. So it will redo them. And now if I look at the loads, you see they're called wind roof 01. So to indicate which one it is exactly. So this makes it very easy to organize your project. Now let's move on to concrete design. I will bring back the previous structure. So in advanced design, we can detail the foundations, so both the point foundation as well as the linear supports. We can design for linear elements like columns and beams. We can also do slabs and walls. So even groups of wall like this, they can be sent as a single wall in the detailing module. So for slabs, one of the nice features of AD is the automatic mesh engine, which means that you only need to draw the external perimeter, so you don't need to worry about subdividing it in smaller pieces and connecting it to all of the other elements. So it's all done for you. So this model already has loads applied on it. The only thing missing is the load combinations. With advanced design, we can use the generator. If you want to create your own combinations, it's possible to do it directly here. You can also copy paste them directly from Excel, or you can also import export Excel sheets. Now to launch analysis, I will click on the analysis tab. will bring the calculation sequence dialog box. So the first thing I want you to notice is this option here to open the current analysis model. So even if I've made changes to the geometry or my loading or anything, I can still have access to the old analysis results. So whenever you make a modification, you don't lose anything. You can always go back to them to consult them. Here I will choose to create a new analysis model and relaunch the analysis. So if you want, we could go straight to finite element calculation and then turn on also reinforced concrete calculation. Or if we wanted to, we could stop at the mesh step. So just to show you a bit how it works. I'll click on OK, so it will mesh my structure, which means the planar elements and linear elements are going to be subdivided in smaller pieces, and they will also be connected together. If we want to modify this mesh, we could change the global mesh option. So this is the easiest method. So I could go, let's say, with a higher density with maybe 0.3 instead of 0.8 meters per element. And I can very easily recreate a new mesh. So this one is very dense. I'll zoom in a little bit. If I want to go back to a larger mesh, back to 80.9. Now, if I want to finish a calculation, I can press on calculation. And as you can see, it will take just a couple of seconds before I can get my result. So what you see here is the displacement for the load case 1D. So this is just self-weight. If you wanted to, you could switch it to, let's say, the 102. So this is the case that has the 1.25 dead load and 1.5 live load. So this is the one with the most likely with the largest forces. And instead of displacement, we could switch to forces. So with forces, we can now select for each type of element, so support, linear, and planar, what forces we want to see. So for supports, we could show, for example, the vertical reactions. We can also display the moments on the beams and columns. So My is moments in the strong axis. And then for planar elements, I could show the MYY, so it's the moment and the Y direction. Now, if you want more details about those values, the one thing you could do is generate section cuts. So section cuts, they can be placed anywhere on the structure. It's as if they were a structural element. So I can place one that go from the corner over there to the edge of the slab over here, and then maybe another one in the orientation. So from here to here. And if I press on post-processing to update the results, we'll see the section cuts in 3D. So if I want to just focus on one of those cuts, I could do is select it, and in advanced design, results will only be displayed on the selection. So it's very easy to isolate an element or a section cut this way. It's the same thing if I wanted to only view results on one specific section slab, I could select it first, and then only this slab would be displayed. If we want to design these concrete elements, the first thing we'll need to do is launch the reinforced concrete calculation. And so now it will be possible to display the results on the screen. So I could display the area of reinforcement for linear elements as well as planar elements. Linear elements. Get two diagrams like this. So this is for the quantity of steel on each side of the column. This is for the Y direction. Same thing for the Z direction. For slabs, we can also bring the reinforcement for X, Y direction for top and bottom. So A, X, B, that's for area in the X direction at the bottom of the slab. Now, if you want to do the detailing, so what we'll do is right click on an element and open with design modules. So in the design module, we'll get a 3D view of the concrete column. And what we can do is click on calculate to generate the rebars. So I'm using all of the default settings here. If we needed to, we could change the geometry as well as the geometry of the elements adjacent to it so that the beam and the columns at the top, modify those if necessary. We can change the design settings as well as the reinforcement settings. So the idea is that if you set them correctly here, it will be a lot easier for you because AD will generate them correctly instead of having to do manual modifications after the rebars were generated. So you can change all of the small details like the bar diameters, minimum, maximum reinforcements, the type of hooks you want to use. So everything can be set here. So this way, when you click on calculate, it will choose the correct rebars for you. If you want to, it's still possible to modify the rebars. If I go to main rebars, I can see the different groups of rebars that were created. And we can also select them in a 3D view. So if you want to modify, let's say this one specifically, I could double click on it and it will bring me directly to the correct group so that it's a bit easier to find this way. So here I have, it's a group of 4 by 4 at 25 M. So let's say I wanted to change them to 30 Ms. So I can very quickly change them and all the results will be updated. We can also check the interaction curves. This is 4 columns only. We have some diagrams with internal forces, and finally the interactive drawing. Drawings include the bar schedule at the top. We also have the elevation and section cuts. At the bottom, we also have the material properties that were used for the design. And so this drawing could be exported as a DWG file, and you can also print it directly. If we've made changes to the element, so let's say we were to change the sides of the column, what we can do then is synchronize those changes back to advanced design so that the finite element model will be modified with those changes. But here I'll keep everything. It's the same idea for the other types of elements. So if I open the support here, right click, open with design module. I can see the foundation in 3D. So for foundation, we can ask it to calculate the sizing based on the soil structure, and then we can calculate the rebars. The module supports different types of footings. Here on the screen. It's possible to define a different soil profile. So this is just the default with peat and around 1 meter of clay. So for foundation, so we have analysis diagram, we have stability diagram, pressures, as well as the overturning moments, the sliding forces. Just like with the column, we have the interactive drawing with all of the details. So we have elevations and section cut with the bar schedule at the top and material details at the bottom. The next module I want to show you is the slab module. So I will select one of the slab region here, right click, open with design module. So with this module, we can use either the find element method or strip method. So I'll keep it as find element based. And now if we move to reinforcement diagram, so what we can show on the screen is what is the area of steel is missing. So if I switch to real reinforcement, and then I will display the delta. So as I add more steel to the slab, you'll see the colors disappear. And then eventually everything will be in dark blue when I've added the required amount. So this is the X direction. So I'll add a new zone along the X axis. I'll snap it on the corner here. Then I just have to draw the external perimeter of this zone. And so now I can select where the first bar will be. So I'll place it somewhere close to the edge of the slab. And now when I move the mouse, you can see the spacing is changing and also the colors are changing based on the steel that is still missing. If I want to change the diameter, what I can do is just turn the scroll wheel. I can change from, so this would be 10 amps, 15 amps, 20 amps. And so it's really that easy to place the rebars on the slab. We can also ask AD to calculate it for us. So if I press on the calculate, it should redesign it, and this time for both directions. So if I go back to the real reinforcement and delta, so everything is in dark blue, so everything's correct. If I go to reinforcement cage, so we can check the rebars in 3D. This is for the top portion, and then there's the bottom portion of the slab also. You can also have both views at the same time, so just to help see what you're doing a bit better. And finally, we have the interactive drawing with also bar schedule at the top, the plan view in the center, and then the material properties at the bottom. So you can customize those drawings. So you can load templates if you want different line styles or anything like that. You can also change the title block. So if you want to have your own logos and everything. And then last thing I'll show you on this module is the strip-based method. So you can either define the strips manually or you can have AD generate them for you. I will use the automatic strip for this one. You can isolate each direction if you want to see them a bit better. So I could always edit them manually if I was not happy with what AD has generated, but for now, I'll leave it as is. Then if I calculate, so AD will calculate it still for me. So what you see here is that for each strip, we have a diagram that shows us what is the required amount of steel and then what was the amount that was placed on this strip. For measured action and for the minor direction. Then we can also view the rebars in 3D. Can have both the view where you define the steel as well as the 3D view at the same time, and then the interactive drawing. So we also have a module dedicated to beams as well as walls or groups of walls. So I won't show them to you today because there's not enough time, unfortunately, but they are very similar to what I've shown you before. They're just a bit adapted to these types of elements. For steel design, what I will do is swap some of the members from concrete to steel just to show you the design feature. Go back to the model view. I will pick a column here and this beam. So currently they are concrete. I will change them to a steel section. And for the section, so I'll use one that was already available here. So W250 by 22. If I wanted to choose a different one, I could directly pick them from the library. So, and if I have a W250 selected, it will bring me immediately to the CISC W section. So I could pick, get something bigger, like a 500 by 72. Okay, so I show all the properties back. So for steel design, we will be using the properties in the property panel on the right side. I won't go through all of them, just some of the most important ones. So first, we can turn on and off the design completely. This is the same thing with concrete and wood also. So if you want to save on analysis time, so this is a good way to speed up the analysis. We can assign a template. So the template would replace all of the options that you see here. So if you have many different members that have the same properties, it could be easier to assign a template instead of having to edit them one at a time. The section class. So if you have a compound section or something that AD cannot calculate the class by itself, you will have to do it. But you could also force a different class for the calculation. For a section like a W250, we can leave it as automatic. There will be no issues there. Same thing if you have one of the parametric section, like let's say you built your own I section or T section, AD can calculate the class for you on those. Then for deflection, so for deflection, you can either check the deflection on like an individual element, but you can also do it for a group of elements. So if you have a beam that was made out of multiple pieces, so there's many reasons why you might want to do it this way. So I could, let's split this one in 10 pieces like this. So if I want to check the deflection of this beam, I don't want to just check the internal deflection on one of these elements. What I want to check is the deflection of the group of elements. So what we can do is group them and then use the super element verification instead of the just normal element verification. It's also possible to activate both at the same time. So let's say we wanted to check the lateral deflection of a column. So it would allow us to check both the inner story deflection with the element deflection as well as the global building deflection using the super element deflection if I were to group them together. So with the deflection, it can be the limit is a fraction of L. So it automatically checks for the correct length and everything. Then for buckling, so typically you can leave it as automatic and it will do calculation correctly, but you can also force different values. So you can either just change the length, so L0 is like just the L, or you can change the KL together. So this would be the LF here. So it can be either just the L or the KL that you force. And when you want to force a different value, so it can be an imposed value, but it can also be like a ratio of the element, a ratio of a mesh size, or a ratio of a super element. So you have a lot of control on how you want to calculate those lengths if you need to modify them. Then we can select if we want braced or unbraced K values. We can calculate lateral torsional buckling. So for lateral torsional buckling, by default, there will be a support at the extremities of each member. We can actually display them on the screen. It's display releases. Oops, sorry, not releases, but restraint. And so we can kind of see it here, but it might be better if I change the view. So you can see those small arrows. Those are all the places where there's a restraint. So In red, it's for bottom, and in green, it's for the top flanges of the beam. So by default, there's one at each extremities, but you can define them differently. So we have a dialog box where you can place additional supports along the length of the beam. So those are not like finite element supports. It will not affect the rigidity of the model. It's really only for the lateral torsional buckling verification. So right now it's 0 and 4 meters because it's a 4-meter column, but we could add, let's say, 2 additional supports, and then it will affect the LTB length. We have the same options for upper and lower flanges. Then at the bottom, we have options that are specific to different types of sections. So for example, the thickness for the HSS sections. We can also add stiffeners for I-shaped sections. So the stiffeners are for the shear resistance of the beam. Now there's a few global options we can also change. So they are in the Analysis tab, those settings. So here we can change things like, what is the maximum or minimum work ratio we want to use. So if you want to design for something other than 100%, we can select how we want to sort the section. So when AD will propose a section for you, so we can decide if we want the smallest one, the one with the lowest inertia, or the, in this case, I'll choose the one that is the lightest one. So that the project is the most economical possible. Then we can put limits like width and height for the element. And finally, so the calculation sequence, one thing we could activate is called chain optimization. So what it does is that at the end of the analysis, AD will choose a section for you, and then it will rerun the analysis automatically. And we can also do multiple cycles if we want to. But in advanced design, the interface is very good to apply changes, so we don't really need to activate this mode. Because since we can view our results while we are doing changes to our geometry, we don't have to rely as much on automatic design tools. We can do kind of in a semi-automatic way. So for that, maybe I will add a few extra steel members just to show you. So I will copy the properties from this column to a few other members. Then I will run the analysis again. And so this time I will go directly to finite element calculation and steel calculation. So for steel design, so we can display the, if you want to, the direct, the work ratio directly, but we can also view some intermediate results. So for example, for buckling, we could check what is the buckling length, or what is the ratio between the buckling length and the length of the element. This could be a very useful tool to see if we've made any mistake during the modeling process. Same thing for lateral torsional buckling, so we can view some of the reference length as well as the ratio between those length and the length of the element. So now if we want to check where those numbers are coming from, like why is this element at 26.6%, we have a dialog box with all of the information. So we call it a shape sheet. And so this will show all of the properties of the elements that were used for design. So if we have a variable section, we can also check for both ends of the member. We can check the deflection verification. So both for element as well as for the super element. So if it was a group them together. Then we have all the verification for the strength. cross section. So the verification are listed here will depend on the type of element as well as the internal forces. So if there was no bending in the z direction, so it would not be shown here, but currently there's forces in all of the different orientations. And at the end, we have the section class. So now if we want to display it in a format that might be a bit easier to print, we can open the detailed report. So this will generate this. It's roughly the same values, but they are just in a different format. It's in a single page instead of being in a dialog box with different tabs. We have all our verification here with the code articles. We have the deflection verification, the section class, and the cross-section properties. Now, if we were to make changes to the model, so let's say we want to change this column and this one here. So maybe let's assign them the smaller here, W 200 by 22, and also do the same thing for the one in the center here, just so we have at least one member with a work ratio higher than 100%, so I can show you exactly how AD will deal with it. So if I made some changes like this, what I can do is I can relaunch the calculation for just the steel design. So this way, if I just want to do some quick verification, I don't need to relaunch the full finite element calculation. So it will be based on the old finite element results. So it's not going to be perfectly accurate, but it's a good way to do some quick tests like this without having to rerun everything. So here there's at least one member that is at 882%. So I think it's this one here. So if I wanted to fix this, so what I could do is use the suggested shape. So this will help me select the correct shape. So when I open this table, we'll get a list of all of the steel members. So if I wanted to focus more on a specific part of the project, what I could do is select them first, and the selection will affect the content of the table. It's a bit easier to manage. And as you can see, AD will propose something. So it's possible that it's not going to be a perfect solution because when you change section, it's going to change the internal efforts inside the elements. But it should bring us very, very close to the like 100% we're looking for. So if I want to accept the solution, I could just click accept all, or I could do them one at a time. So when I click a solution here, it automatically fills it. But I can also assign a different one. So maybe I wanted to have two W200 by 46. So I could select them both like this. I can also bring up the design result. So if I click on the currently assigned section, I can see exactly how it was calculated and where the problem was coming from. So we'll try it with those members. So I will need to assign them. And now if I recalculate the design, we should get somewhere close to 100%. But like 95, or the last one was there previously, so 95, 90%. So it was very, very close. And so this table is very useful. It makes it very easy to quickly apply changes to your model. So this is why we don't have to rely on like blind automatic optimization. So it's also possible to group them. So I could group them by, when it's by element, that means each element is optimized individually. But if we group them by section, that means all of the elements with the same section will be grouped together. So I see there's 14 elements with a W 100 by 30. There's 14 elements with this one. So if I wanted to take all of the W 46, 200 by 46, I could replace them with just one click. Same thing by design templates. So those are the templates I talked about earlier. By name, so if you named your elements with something appropriate for your project, So you would see them listed here. Currently, it's all linear, but I could name them, for example, with the column and the name of the axis. And then we have per system. So this model was already grouped in a subsystem. So I have a system for columns, beams, and then a different group of columns. So this is because we have two different floors. And so I could replace all of the columns at the same time. I will now conclude the presentation. Thank you everyone for watching. If you have any questions, I will be available to answer them. You can also send them by email at the addresses listed here. And don't hesitate to ask us if you want a trial license to try the software on your own. Once again, thank you for watching.